Okay, good morning. Welcome to
Math Practice number 102.
Math Practice number 102. So today we started Beast Academy B. And the first thing in Beast Academy B is multiplication, right?
Yep.
So the first thing it looks like they talk about in your problem book are learning a little bit about multiplication tables. Ever heard about multiplication tables before?
Yeah, in my book.
You have in the book when you read the book, okay. Well, so I thought we'd do a fun little practice just about what do the tables mean. So this is an addition table to start with. And it just means each square in this table means you do something with the two numbers that represent that square. So for example, this square here is a 2 and a 2, and since this is a plus table, what is 2 plus 2?
It's 4.
Okay. Now, do you think you can fill in the whole table?
Yeah.
Okay. Where do you want to start?
Let's start at the 1.
Okay. So what does this square represent?
Represents 2.
Okay. You don't need to circle them. I was just highlighting that square. So this square is a 1 and a 1.
It's 2.
Just plus. It's a 1 and a 1, and these are all pluses, so that's 2. What's this square?
1 plus 2 is 3.
What's this square?
1 plus 3, which is 4.
What's this square?
2 plus 1, which is 3. And this is 3 plus 2, which is 5.
Okay.
3 is 3 plus 1 is 4. 3 plus 2 is 5. And 3 plus 3 is 6.
Okay, so there's an addition, just a very simple addition table, right? And you notice it has a lot of neat properties. It looks like across this line here, the numbers are the same. So that 5 is that 5, that 3 is that 3, this 4 is that 4.
Mm-hmm.
So there has some symmetry to it, but it's not too hard to put together. Do you want to do a times table real quick?
Yep.
Yep. Okay. So let me erase these 9 numbers. Maybe I won't do the best job in the world of erasing them, but close enough, right? And let's just change this to a times. Okay, and we'll make our first ever times table. Okay, where would you like to start?
At the ones.
Okay.
Well, 1 times 1, as easy, it's just 1.
Okay.
1 times 2 is 2, and 1 times 3 is 3.
Okay.
2 times 1 is just 2. 2 times 2 is 4, and 2 times 3 is 6.
Ooh, okay.
3 times 1 is 3. 3 times 2 is 6. And 3 times 3 is 9.
Cool.
I think I noticed something. These are all perfect squares.
Oh, very good. Very good thing to notice. Down the diagonal here, these are all perfect squares. Because it's 1 times 1, 2 times 2, 3 times 3.
Yep.
That's a good thing to notice. It also has this reflection property. If you reflect on this diagonal line like that 6 becomes a 6, the 3 goes to 3, 2 goes to 2.
Yep.
You want a challenge question about this one?
Yeah.
What number is the same on the plus table and on the times table?
Well, the 2's are the same here.
No. Which number, when I had the plus table and I erased all the numbers and then we wrote the times table, in one of the squares I wrote the exact same number as before. So something in the plus table was the exact same number as it was in the time table.
Is it 4?
Ah, 2 plus 2 is?
4.
And 2 times 2 is?
4.
So no matter what, if it's plus or times, with 2 2's you get?
4.
That's pretty neat, right?
Yeah.
Alright, good job. There's another number that works for too, by the way. I'll leave that as a challenge problem. There's some other number that when you do x plus x, it also equals x times x. I wonder what other number that could be, but it definitely works for 2, because 2 plus 2 is 4, and 2 times 2 is 4. You can think about that. Alright, honey, good job today. Good job.